In this video, we're going to take a look at some specific types of sequences, some properties of sequences that we might have, and then we'll look at several examples of those. So let's first define what it means for a sequence to be increasing. So a sequence is increasing if and only if the nth term is less than or equal to the n plus 1 term. Right? So every term, every subsequent term should either stay the same or get larger, and so that's an increasing sequence. A decreasing sequence is kind of goes the opposite direction. Right? So a sequence of real numbers is decreasing if the nth term is always greater than or equal to the n plus 1 term. Now you should note that some textbooks would not define these as increasing and decreasing. Instead, they might define this as non-decreasing and this as non-increasing. So just be really careful what your textbook might say. But the textbook that I'm using and basing my notes on, it defines increasing in this way and decreasing in this way. So then we have a sequence is monotonic. So it's monotonic if it is purely increasing or purely decreasing. So if it's only increasing or decreasing, so it could stay constant through some terms, but as long as it doesn't increase some and then decrease, or decrease some and then increase, as long as it's not doing both of those, then we say it's monotonic. All right, so let's look at several examples. We'll take a look here. All right, so let's look at this sequence right here. So it's defined by 1 over n. And so that sequence, when n is 1, we have 1. When n is 2, we have 1/2, then 1/3, then 1/4. So this sequence, as n gets bigger, our value, our fraction, is going to continue to get smaller. So it is decreasing. It is monotone. It is converging. It is getting closer and closer to 0. So yes, it is convergent. And is it bounded? Yes, this thing is bounded. So remember that a sequence is bounded if there exists an m in the natural numbers such that the absolute value of our terms in the sequence are always less than or equal to that value of m. All right, so yes, this thing is bounded. Nice. Let's look at another example, something that's maybe a little bit more exotic. So here we have our sequence is 2 plus 1 over n if n is even. It's negative 2 minus 1 over n if n is odd. So when n is equal to 1, we have 3. When n, oh, I lied, that's not true. When n is 1, we are in this odd portion. And so we'd have negative 1 minus 1, so we would have negative 3. When it's 2, we would have 2.5, positive 2.5. Then we would have negative 2 1/3. Then positive 2 1/4. Right? So is this monotone? No, it goes from a negative to a positive back to a negative. So it's jumping back and forth. It is not monotone. Is this convergent? It is not convergent because it's going to be continuing to jump back and forth between these positive and negative numbers. Is it bounded though? Yes, it sure is. You could bound this. We could choose the number m to be 3. And so no matter what term we have, the absolute value of the term in the sequence is always going to be less than or equal to 3. All right, so that's example 2. Let's take a look at another example. Here we have 5n minus 2 over n plus 4. And so when n is equal to 1, we'd have 5 minus 2 over 5, so we'd have 3/5. When n is 2, we would have 8/6, which is 4/3, but I'm going to be a little bit lazy here in this moment. When n is 3, we would have 15 minus 2, so we'd get 13 on top. On bottom, we'd have 7. When n is equal to 4, we'd have 18 on top and over 8, which again, that fraction would reduce. So this is what we have going on. Is this thing monotone? It sure is. Yes, it's monotone. It's going to, so we go from 3/5 to 8/6. Right, so we're getting larger each time. The top is growing quicker than the bottom. So this is getting larger. And, let me back that off. So it is getting larger. When I said the top is growing quicker, it's actually growing kind of at the same pace. It is still converging. In the long run, this thing is going to converge to 5. This should be getting closer and closer to 5. But it should always be less than 5. It is bounded. That's what we have there. Our next example, it is sine of n, and so those values of n, this is one that I'm not going to be able to write out real easily, but it's going to the sine function is an oscillating function. So if we are just going to evaluate that at integer values, sometimes it will be positive, sometimes it will be negative. So it is not monotone. It is oscillating, so it is not going to converge. However, we could put a bound of, it's always going to be between -1 and +1. So it is bounded. So that's our example there. Example 4 already. Example 5, here we have something where we have 3 minus e to the -n when n is even, and we have just the number 3 when it's odd. So our very first term is going to be 3. When n is equal to 2, we will have 3 minus 1 over e squared. And then we'll be back to 3. And then we'll have 3 minus 1 over e to the 4th. And so this is going to bounce between 3 and 3 minus e to a power. That 1 over e to a power is going to converge to 0. And so overall, the sequence is converging to 3. But it's going to be bouncing back and forth between 3 and some number that's a little bit less than 3, and then 3, and then a number that's a little bit less than 3, and then 3, and then a number that's a little bit less than 3. But the number that's less than 3 is going to continue to get closer and closer to 3. It is bounded. That's bounded above by 3, below by 0. So we do have a bounded sequence. The next example, we'll do one more, and then you can try some other examples on your own. Here on this last example that we'll take a look at, here we have 2 plus -1 to the n over n. And so there, when n is equal to 1, we will have just the value 1. When n is equal to 2, we'll get 2.5. When n is equal to 3, we'll get 2 minus 1/3. So we'll get 1 2/3. and then it will kind of continue to go on. It is not increasing, nor is it decreasing. It's going to be bouncing back and forth. It goes from 1 to a number bigger, back to a number smaller. Right? So it's not increasing, nor is it decreasing. It is not monotonic. It is going to converge to 2 in the long run. So even though it's bouncing back and forth between those values are both going to be converging to 2. And is it bounded? Yes, it sure is bounded. So we don't ever get a number that is larger than 2.5. So it's bounded above by 2.5. It's bounded below by 1. So we have this bounded sequence. And so there's some other examples that you can try on your own, and let me know how you do. All right, we will talk to you guys later.